Today's topic is reduce costs and produce better models using the InfantStore machine learning platform. In today's machine learning world, there are two conflicting requirements that are causing a number of machine learning projects to stall or to not reach production. In order to get high quality models, better models, you need to train with more data. That's just a fact of life. But data management tools for unstructured data are not really available today. There are data management tools such as Databricks and Snowflake for structured data. There are, however, no tools for unstructured data. Now, the other conflicting factor is that more processing can become dramatically costlier pretty fast. Unless you keep an eye out on the cost of your processing, you can easily run into 10 times or even 100 times what you had budgeted for in your machine learning activity. The InfantStore machine learning platform has been designed from scratch to solve these problems. We will help you prepare better quality models in a cheaper, lowest cost fashion. Let's talk about storage tools that the InfantStore machine learning platform brings first, and then Jitendra will dive into the compute tools and talk about the cost of running it in interesting ways. The storage tools that we bring to the ML workflow are InfantSnap and InfantSlice. InfantSnap is fine-grained snapshots of cloud object stores, fine-grained down to the millisecond level. And InfantSlice is an improvement on InfantSnap where you can get a slice of data ingested between a start time and an end time. InfantSnap is useful for many objectives such as true data provenance, experimenting with different parameters, perhaps starting from an experiment that resulted in good values. You now have the guarantee that that data that was used to train your good run is available perpetually. InfantSlice has several different uses. The first of which is you can take a slice of data, perhaps from the time you last trained your model, and rerun your training session, score it, make sure that the model continues to be relevant or data drift has not happened. You can also use it for inferencing. As a matter of fact, if data is pouring into your cloud object store, you can take a slice of that data and run inference against that. We will see an example of this in our demo later in this webinar. Let's take a deeper look at InfantSnap. Consider a bucket with many objects in it. At time t0, it has a number of objects. Time moves forward to t1. Let's say 3 more objects were added to the bucket. And at t2, somebody decided that some of those objects were either wrong or something needed to be changed. 2 of those 3 new objects got deleted. As you can see now, if you start your training at time t1, the view that you get from that snapshot will be exactly that view of the bucket with the 3 new objects. Had you started your training at time t2, you would have those 2 objects that were deleted not visible in the view. What this shows is that when you go back and look at a specific experiment run, you can figure out exactly what data was used for it, and that view of the bucket is available perpetually for you to go back and experiment with. There are regulatory reasons for which you may want access to the specific data that you trained with. There are also just plain experiment reasons. When you don't know whether the data has changed or not, going back and starting from a run and changing hyperparameters may not necessarily be useful or valuable. You're changing too many variables in that particular attempt. Let's take a look at InfantSlice. Let's say time t0, you have a number of objects. Time moves forward to t1, you have 3 more objects added to the bucket. If you ask our system for an InfantSlice of data from start time t0 to end time t1, you will get a view of just the objects that were added in that duration. All the objects that were present in the bucket before t0 will not be visible to the InfantSlice. This helps you with doing things like data drift protection. You can also use it for taking slices of data, perhaps using it for continuous learning of your model if your algorithm is capable of that. If your algorithm is not capable of continuous learning, you can, of course, retrain from scratch using the new inference slice of data and score it and verify that you have not suffered from data drift. Let's take a look at the service architecture as deployed in AWS. And the Azure version will be very similar to this. This is a good example cloud implementation for our purposes. As you can see, the S3 bucket is the central point of all of our activities. The ingest pipeline on the left is something we don't mess with. We like to keep that unaltered because often companies have very carefully architected and carefully managed ingest pipelines. We do not believe in putting a proxy in front of that or any such invasive technology. All we require is S3 events from that S3 bucket need to flow into our S3 events Lambda. We use this Lambda to create a metadata layer in a DynamoDB instance that gives us access to InstantSnap. The read interfaces are Web HDFS emulation. This is very convenient for native Hadoop tools like Kubeflow, Spark, even Elastic MapReduce. We also have an auto-scaling S3 proxy that helps native tools like Boto3 clients written in Python and other cloud-first applications to access our snapshot-based view of the bucket. In the bottom, we have a dotted box showing InfantStore's MLflow as a service. This is an interesting enhancement to our platform. In our platform, we chose not to build our own proprietary workflow management systems. We instead adopted MLflow. We've extended MLflow with plugins, and we've added capabilities to MLflow that are specific to our storage enhancements. The end result is a fully hosted MLflow version. You don't need to start any database instances. You don't need to start any service instances. It's multi-user in that you can have data scientists have their own view of the MLflow workspace for storing artifacts, experiment runs, etc. Again, this will be part of a demo at the latter half of this webinar.